Hello friends, welcome to Shiksharthi. In this video, we shall be talking about 3-digit squares. Now while we'll be talking about 3-digit squares, our focus in the first half of the session would be on accuracy only. But during the second half of the session, the focus would be on accuracy and speed both. So, let's start. So what we are doing here is, I am taking a 3-digit number like HTU. Now what does HTU symbolize? H is nothing but my hundreds placed digit, T is my tens placed digit, and U is my units placed digit. And what am I supposed to do? I am supposed to find out the perfect square. So if I refer to my very first video on perfect squares, on 2-digit perfect squares, I had given you a small formula to start with. To start with, now we are talking about 3-digit perfect squares, so we'll start off with the formula on the same. So how do we start? So before I start, let us relate it with this algebraic expansion, as we had done in the earlier video as well. So had I taken a+b+c whole square, this is just like taking a 3-digit square like HTU whole square. Now while doing so, how many things that we are getting? How many terms are we getting here? We are getting 1, 2, 3, 4, 5, 6. We are getting 6 terms here. But when I'm talking about a perfect square here, I need to understand that these are the lines of separation. So starting off with the leftmost extremity, which I said earlier also, let us imagine this is in the form of a train, in which my leftmost extremity is the engine of the train, followed by coach 1, coach 2, coach 3 and coach 4. Right? So what am I supposed to do in the leftmost extremity? I'm just supposed to find out the square of the digit, which is h square, followed by, this is 2 into h into t, followed by a t square plus 2hu, followed by a 2tu, followed by a u square. Right? I hope you'll be able to understand the formula better if I take an example for the same. And we will take a very small example. Now when I say I'm taking a small example, I am basically talking about a 3-digit square of the form a+b+c, where all the 3 digits are different. So I'm taking an example for this. So I'm going to take a example like this. So if I take 123 whole square, this becomes my hundreds digit, this becomes my tens, and this is my units digit. Right? So what am I supposed to do? I'm supposed to start off with h square. So 1 square is a 1, followed by 2 into h into t. So 1 into 2 is how much? 2, 2 into 2 is 4. Followed by a t square, which is 4, plus 2 into 1 into 3, which is 6. Right? Now how much is 6 into 4? 10. How will I write 10? 10 has to be written in such a way in which the units digit remains at the same platform and the remaining digits are to be written in the subscript. For this, refer to my first video on squares, wherein I have talked about how to do this. Okay, now followed by a 2 into t into u, which will give me how much? Followed by a 3 square, which is 9. For the final answer, I need to go from the right hand side to the left hand side. So this 9 comes down as such, 2 comes down as such, 1 plus 0 is a 1, and 1 plus 4 is a 5, and this becomes 1. I'll take one more example, and we will take an example of the same in the same format. The same format is, I'm taking a 3-digit number, the square of which has to be found out, wherein all the 3 digits are different. Okay, so let us say I take a 789 whole square. So what am I supposed to do? 7 square is a 49. Now 49 is the engine of the train, which has to be written as such. The next is 2 into h into t, which is 7 into 8 is a 56, into 2 is a 112. Now in 112, you have to write down the units digit as such. The remaining digits here are 11. they have to be written in the subscript format. So they go down. To be followed by, now how much is 7 into 9? 63, 63 into 2, 126. 126 plus 8 square, which gives me how much? 190. Followed by 8 into 9, which is a 72. 72 into 2, 144. Followed by an 81. So for the final answer, I am supposed to come down from the right hand side to the left hand side. Right? So 1 comes down as it is, 8 gets added to 4, which makes it a 12. 12's units digit comes down, the tens digit gets carried over. So this becomes how much? 15 plus 0 becomes 15. 15's units digit comes down as such, 1 gets carried over here. So 19 plus 1 is how much? 20, right? So 20 plus 2 makes it how much? 22. Now 22, the units digit is 2, that comes down here, and the tens digit gets added to the next subscript. So 11 plus 2 makes it a how much? 13. Now this 13 needs to be added here, which is a 62. Correct? The more you practice, as advised, the more you practice every day, and to be more precise here, let us practice half an hour every day, and believe me, there will be a point in time wherein you yourself will disbelieve your speed. So when I say disbelieve, I am talking about the positive side of the coin. I mean, there will be a point in time wherein you say that, hey, I am doing the same calculation within 7 seconds. I mean it. With the help of which method? The mother method. I do not require special methods. Right? So why? Because special methods are applicable only to very few questions. And if you are writing any exam, even the examination conducting body is aware of the fact that people mug up such kind of special methods. So don't mug up, have methods in place. This I have been saying, and I'll keep on saying. Right? Okay, let's come back. So now, as discussed, the focus would be on speed and accuracy both. See, we have already talked about the method. We'll take some more examples so that you are able to understand it better. And now we will be taking slightly different examples. So which are the examples that I'm going to take now? Examples, how many 3-digit squares can we refer to? These are the 5 varieties of 3-digit squares. We have already talked about the first variety. We will talk about these varieties as well. Now which variety is this? I am taking a 3-digit square in which exactly 2 digits are the same, but the third digit is different. And the last variety that I'll talk about is, which I feel is the easiest one. This is the easiest in terms of why? Because, or it is supposed to be the easiest. Why? Because all the 3 digits are the same. Right? Okay. So now let us focus on these. To start off with, let me take a small number. Now when I take a small number, I could have taken a smaller number like a 3, 3 and a number, let's say, bigger than this. Let us say a 335 whole square. I don't require a special method to find out the square of a number which ends in 5. I'll repeat, we can just do it with the help of generic methods. Now the focus is on speed. So let us see how to go ahead. 3 square, 9. 3 into I have the answer. So if I say that the answer can be calculated in 7 seconds, I mean it. But yes, right from the day one, your focus should not be on speed. Your focus should be on accuracy. Now I need to decode the answer, which you know how to decode it. Let's revisit it. So 3 square is a 9, 3 into 3, 9 into 2, 18. 3 into 5 into 2, 30, plus 3 square, which is a 39, 3 into 5 into 2, which is a 30, plus finally it is a 25. Why? Because 5 square. This 5 comes down, 2 plus 0 is a 2, 9 plus 3 is a 12, 1 gets carried over, 12, 1 gets carried over. So now tell me from where did this extra 2 come? Let's see. 5, 2 plus 0 is a 2, 2, 2, 1 gets carried over. So are these correct? Yes, they are correct. Yes. Let's take few more examples. The next one that I am going to take is slightly a bigger one. Let's see whether the answer is correct or not. So 8 square is a 64, followed by 8 into 8, which is 64 into 2 is 128, followed by 9 into 8, which is a 72, 72 into 2 is 144, 144 plus 64. I'll repeat. Now this is 144. How do I get a 144? 9 into 8 is a 72, right? So 144 plus 64 makes it how much? So this should have been how much? Confused? Let's come again. 8 square is a 64. 8 into 8, 64 into 2. So now you would see, if I speed up, I tend to make mistakes. So we will see whether the answer that we have got is correct or not. So what I was trying to emphasize on the fact is, let us first focus on accuracy only. And then we followed by, let us say, speed and accuracy. So the next one here is 9 into 8 is a 72. 72 into 2 is 144. 144 plus 64 should give me 208. So this answer should be a 208, followed by a 144, followed by an 81. Now for the final answer, I need to come down from the right hand side to the left hand side. Let's see. This 1 comes down as it is. 8 plus 4 is a 12. 1 gets carried here. So we'll have to change these answers. 1, 8 plus 4 is 12. 1 gets carried here. 15 plus 8 is a 23. 22 plus 8 is a 30. 3 gets carried here. So 15 and 64 makes it a 79. So the last example here. Let us take an example like a 888 whole square. Now I'm leaving it as it is. Now in every video of mine, I'll be leaving 1 or 2 examples either unsolved, or I'll be solving them and leaving as it is, so that I'm giving you food for thought. Is this one of the easiest examples that I can take in the world? Of course. Why? Because the first would be 8 square. Now this 8 square 64 has to be multiplied by a 2, which is 128. 64 multiplied by a 3 is 192. To be followed by, not 192, 128, which is why I was trying to give you some food for thought. So to be followed by 128, to be followed by 64. Similarly, if somebody gives me a question like, oh, do you know how to find out 555 whole square? Do you know how to find this out? Yes, with the help of mother method. Do it on your own. Can you find out 999 whole square? Yes, I have discussed it in my earlier videos as well. So I hope I discussed something which brings some knowledge to you, right? Please don't forget to like, share and subscribe to our channel. Thank you so much. Until next time we meet, goodbye.